Design iterations that once took weeks are now completed in a matter of hours, and complex geometries that were previously impossible are now routinely produced on demand. This is the reality being realized through the advanced 3D printing technologies and streamlined workflows pioneered by industry leaders like Sculpteo and Jib, two companies who have worked together to create a device that integrates an eye camera and a tablet, specially designed for people with neurodegenerative diseases or severe motor disabilities. Using Jib eyes, users can now interact with their environment, communicate via pictograms or a keyboard, and much more. Joining us today are the CEOs from both companies, Alexander Dorsetti from Sculpteo and Thomas Grohl from Jib. Can you walk us through the design and development process of Jib eyes and what the primary mechanical and design challenges were in integrating an eye tracking system with a tablet?
So basically, just to summarize why a person would need an eye tracker, it's basically made for people who have different types of pathologies, but that affect heavily their ability to move their bodies as well as to be able to express themselves out loud. So a lot of our users are people with ALS, who cannot, at certain stage of development of the disease, they cannot express themselves through voice, and they cannot move uh, basically any part of their body. So the only element they can move is their eyes, and through that they can interact with the eye tracking system. And the other main users being kids with certain pathologies that also affect their ability to express out loud, but also to learn ordinary language. And for them, they also need pictograms system of communication. So I think in the US it's quite well known now. AAC, augmented communication, and something that is very useful for those kids. So basically, what we provide is a tablet, which is basically the digital interface, whether it's a computer like Windows tablet, or whether it's an iPad, and we need to connect this with an eye tracker system. So it's usually a camera that uh, um, um, gets the information of where the user is watching, so that we can move the mouse through the interface. And all of this, it has to be structured together, so they kept together through an element, and that's where the casing that we print through Skelteo enters. So basically, it's two things: the idea of holding the camera at the right angle, because it's really essential that the right angle shows directly to the eyes, the eye tracker, so that it can get the sight pretty reliably, precisely, and at the same time protect the entirety of the tablet and the eye tracker camera. And in the end, we add an arm basically that's holding the whole thing together, and put it in front of the user. So that's basically the entirety of the system that we provide, and the casing is very essential for the eye tracker and the camera and the tablet. We have a wide variety of mounts, so we need to have the casing adapted for those mounts. And at the same time, we also have different types of tablets that can be used. And in the future, we will also have different types of eye tracking cameras that I use. So we need something that can be quickly adapted for all those situations. So we are basically forced to use 3D printing, because any other types of production would be not as flexible to provide something adapted to each situation. And in that kind of context, it's perfect to have an initial design, and we can adapt every time and basically print on demand based on the reality of the situation and also the level of demand. So we don't also need to have a huge stock, and we can completely adapt to every case of individuals.
I think this is typically the kind of projects that we like and that we have. I mean, people come to 3D printing for different reasons. I would say that the two main reasons in general, it's design freedom, that they can make things that are not feasible is a way, in another way, or the other big entry door is production flexibility, and most of the time it's both. I mean, because they need 3D printing for production flexibility, then they can use also the design freedom which is offered by those technologies. And what I really like with this project is the fact that um, the 3D printed part is wrapping around existing elements to create a device in itself, but it's not a device, it's a combination of different existing parts, like a screen and the different parts that Thomas mentioned. The part is not, let's say, it's not designed forever. I mean, it's going to evolve depending on the end customer's needs. And the additive is just perfectly suited for this because, as Thomas already mentioned, but you can change the design each time. So it's not so much about printing the exact same file each time, but to have the right connection between existing elements. And in general, additive is when you need to connect existing elements. Additive is most of the time a very good solution because it's very good at connecting existing stuff together, because some of those existing stuff can vary, can change during the time, and you want to have this flexibility in the manufacturing.
Do you want to tell me a little bit about the type of additive manufacturing you're using? What kind of 3D
Yes, for
printing?
sure, for sure. We, let's say, we are specialized in powder-based 3D printing, but not only, but that's the main installed base that we have is MJF machines. So we are a HP digital manufacturing partner. So we are 5 in Europe with this tier 1 level of partnership with HP, which is based on our production capacity and of the quality and industrial production that we make. So we work a lot with HP because their machines are really suited for production, for good repeatability. And we also have EOS machines for SLS production, which is another of our big installed base, which allows us also for different kind of projects, for some very high precision product on very small, like surgical devices, or also for having bright white parts to be able to color them after, to dye them in bright colors and so on.
And then for this Jib Eyes project,
Yes.
do you only use one type of additive manufacturing?
Yes, exactly. So this was made on MGF TPU, and the TPU is a flexible material. So it's a urethane-based flexible material. And the important thing is that Sculpteo has been part of BASF since 2019. And inside BASF, there is a 3D printing division called Forward AM, which has no spin-off from BASF very recently. So it's not BASF anymore, but we are still working very closely with them and we'll join them after. So it's the fact that we are integrated in a material business is also very interesting for us because we have access to all the R&D and all the material know-how.
Okay, great. So what were the key mechanical design considerations when developing Jib Eyes to ensure the comfort and the ergonomics and the usability for the individuals with varying levels of motor disabilities? You started to touch on that a little bit, Thomas, but if you could go into that more with those key mechanical design considerations.
So basically, the main issue would be really adapting to every type of tablet. The main tablet that we use is the Surface Pro from Windows. And since we've started with those tablets, the generation has evolved a lot. We started with a Surface Pro 7, and then there was Surface Pro 7 Plus, and then 8 and 9, and then right now I think we are at 11. And every time they change the model, they change where the buttons are a little bit, also the size of it all, and every time it changes completely the design for us for the 3D casing. So every time we need to redo the design, and every time we need to adapt, which is why also we like to basically on demand print, because that way we can be more adaptive every time those elements change.
Can I ask you about the eye tracking sensor? Where is that located?
It's always below the tablets.
So is it part of the case?
It's put inside the casing. So basically the casing as a whole, that's perfectly fitting the eye tracker. And so basically you have the eye tracker that's below, and then a small hole through which the cable can go to go up towards the input plugs of the tablet.
Did you design that eye tracker yourself, or do you buy those off the shelf, or how does that work?
We currently work with a company, a Spanish company, and in future we're gonna develop a partnership with different companies as well, with the idea of having a variety of different suppliers for this type of take. So that explains the requirement of a very adaptive product.
And then what about the software that connects all of it? Is that your software?
So we need several softwares. It's because it's a complex um, overall system. There is an initial software that's kind of a firmware slash initial software that's provided with the eye tracker. So that would be made by the supplier of the eye tracker. Then we have specific communication softwares, some that we get from other suppliers, and we are at the moment working on our own software for that kind of thing, for communication. And after all, there's also the need of environmental control, and for that it's our own software that we provide. So the idea is that we provide most of the softwares, but we also add some extra ones if there is some extra requirement for the customer. Every customer has complete different profile, and we try to adapt as much as possible to the reality of each individual.
I would just add that tolerances in additive, especially on bigger part, is quite challenging. So if we are talking about a perfect fit to fit each kind of device and so on, I think the TPU was also a good choice because it has a slight flexibility, which is acting a bit like, like a flexible casing on the phone or something.
And then is the material itself pretty durable? Because if the device falls, you want to protect those components that are being housed.
Yeah, it's really one of the requirements of the product that we make, to make sure that because sometimes it's used in medical institutions, for instance, and you have a lot of professionals that are touching the product and then moving it, and then because it's a special setting, then sometimes the equipment is a bit violently used by many people. So it really needs to be basically surviving all those hard conditions. Maybe I'll let Alexander explain in terms of like the material that has been used, how it's.
Yeah, I mean, one of the main benefits of TPU is really it's a very resistant material to abrasion and to flexibility. So the part that we print are tested on like fatigue test on hinges or on resistance to high abrasion. It's a very much used material for insoles, for example, or even outsoles. So it's very resistant to abrasion. I think that what's interesting in this project is that the material needs to be solid in itself. I mean, resistance to tear and to abrasion and to shock absorption, but also to, I guess, kind of act like some protective element also for the electronics inside or the devices inside. And maybe in some other versions, if needed, if there would be need to even protect more, we could add, on the more some, for example, bumps, lattices, or elements to even protect even more the parts. That's the interest of TPU, is that it's a very good material for protective elements.